Hi, I'm Shreepad. In the next few minutes, I'll walk you through the loan approval model I built, explain each design choice. I'd like to show you the alternative methods that I've tested, and I'd highlight the biases I found and how I address them. Biases both in the dataset and the model that was trained on this data. So that is just me running the code, but most of my code can be understood through the additional report MD and the loan model MD, which I'd be covering now. So to begin, starts with a basic EDA, categorical values. The first thing I note is there are some values with very minimal data, so despite whether they show biases or not, I would not really bet on it, is the first assumption that I can make. The second is the approval rates by the charts don't seem to be much, so I have taken a statistical analysis, and that has really improved my understanding. Likewise, for that was for categorical values. Likewise, for continuous variables, for instance, we have by income. So higher the income, more likely you are to be approved for loan. Higher your credit score, even more likely than by income, as you can see. And more the loan that you're asking, you're less likely, slightly less likely to be approved for loan. And several estimates that I've made personally for myself. So the conclusion of that was whites and Asians have higher approval rates than blacks and Hispanics, which are the least. Males have higher than females, and especially more than non-binary, which, as I've stated, there's very minimum data on it, which is to be noted. Then individuals in age group of 25 to 65 years old have a slightly higher approval rate. So next comes my modeling. So I have used logistic regression with pruning for SHAP analysis. And the way I've done it is first use a KNN imputer for any missing data. And I have used this because it can note the similarity between the applicants and preserve any relations like between their credit scores and their incomes, which would be a better option when we're dealing with such variables instead of directly using mean or median. I have also binary encoded sensitive variables, which I have marked early on in this code. So like disability and criminal records, they are encoded into 0 and 1. So this makes the model easier and more fair to compute and interpret. And I have one hot encoded other categorical variables. It's like employment type and education level. So the reason this was done is so that the model can learn these effects separately, and as I have checked through my own correlation map, there has not been much correlation between the data points, so it felt fair enough between continuous numerical values as well. I have used standard scaling, for instance, like for credit score, income, and loan amount. The regularization would have applied a very large penalty for any of these, so I have used a standard scale for it. The next comes the SHAP analysis. I started with a basic L1 penalized score for the logistic regression, and it is an inbuilt feature to help against overfitting. I have used a linear explainer which really which really uncovered and explained some of the inherent biases in the data before the model training, which I'm going to come to right here. So this model is one that I've used AIF 360's reweighing, and later on I have applied Fair Learning's threshold optimizer, and overall it improved my accuracy by 2%, and my F1 score by 2%. But I decided not to submit this, not to go ahead with this for the specific fact that SHAP analysis is providing me this sort of interpretability, which is far more important for me. So for SHAP analysis, I've selected the top 20 features that directly seem to impact the model's performance, the loan approval rate. So as you could see, credit score and income have the highest scores, but you do have potential biases. Being a gender male could get you more higher chance at approval rate. Uh, Having a criminal record could reduce it. Having a disability could reduce it. Having, let's say, high school level of education and not anything greater can reduce it. Being in a part time can reduce your chances at getting a loan approved. And so this is the numerical, this is the data. This is again the same insights that I've noted down. I've also run some scenarios by myself and I've noted these down. A lot of these reports will be found inside additional reports. So I'm skipping through it right now. So my model's accuracy is 63% with an F1 score of 63%. And so again, in my additional reports, I have highlighted other models that I have used, such as basic logistic regression, which has a 2% increase, but it does not allow as much as interpretability as my SHAP2 pruned logistic regression. I've also tried out cat boost, voting ensemble. I've tried out all these methods, but eventually this is the model that I chose for these reasons, and more or less the accuracy is nearly the same for most of these models, so I don't think the 2% is going to make a large change. Rather, using this simple approach is what I had opted. So yeah, once the model has been trained, I have run some auditing for the model's behavior. I have run first a univariate auditing. So for instance, males have a 59% chance of of having their loan approved, while non-binary have 27% chance, which is a huge disparity indicator. And females have 42% chance. And likewise for race, Native Americans have 70% chance, but as I've shown earlier, there's very limited data on them. So that is one thing I keep in mind in my outputs. So yeah, the univariates are one thing. Then I have used intersectional analysis, where essentially it is criminal record, gender, and disability. So over here, a female without criminal record or disability has an approval rate of 48%, while a male without a criminal record or disability has even higher, 66%. So that firstly indicates a potential bias, and I've already run cross validation on how maybe gender could influence criminal records or anything else, and I've also had a heat map, and none of them show strong interrelatability, so this is directly on gender. Likewise, I have used metric frame for classification, which is typically for classification, but it has really been useful here. It has reiterated what I've been looking at the data so far. For instance, males have a higher selection rate at 59%, and the model has a low FNR, which is false negative rate, which is basically how often my model misses. But in non-binary, we have low selection rate and high FNR. That means my model is missing, which again links back to not having enough data on them. While the model has learned pretty well, there is not enough information to regard it as such. Then likewise, I have run fairness metrics with a binary labeled data set. The AUC score is 67, and the disparate impact is basically hidden discrimination. So while things might look fair, what is there an impact, a correlation between any of these properties and the loan approval rate? And definitely there is. The disability status and the criminal record, which we have already seen earlier, show very high. So usually by this 80% rule, the threshold is supposed to lie between 0.8 and 1.25, but these have crossed 2, and this is 2.8. So criminal record really impacts the loan approval rate, and that's what I got out of it. So at the end, my model's performance is 63%. My F1 score is 63%. Thank you.